Hello students, welcome to the second lecture on generic IKS, Indian Knowledge System, Ancient Indian Mathematics, Overview and Contributions. I am Pratul Gadagkar from Department of Mathematics and I will be delivering the second lecture on the same. So in this lecture, we are going to discuss about some great Indian mathematicians. So we are going to discuss firstly about Brahmagupta and his contributions. Let me introduce you to Brahmagupta and his early life. Brahmagupta was an Indian mathematician and an astronomer. He is the author of two early works on mathematics and astronomy, the Brahma Sphuta Siddhanta. Brahmagupta first described gravity as an attractive force and used the term Gurutvakarsanam in Sanskrit to describe it. In the year 628 CE, he composed the Brahma Sphuta Siddhanta, which is believed to be a revised version of the received Siddhanta of Brahmapaksha school of astronomy. Brahma Sphuta Siddhanta, Brahmagupta's significant work. It composed of the following three treatises. Brahma Sphuta Siddhanta, which was composed in 628 CE, Khandaka Khadyaka, composed in 665 CE, and Grahanar Kajanana, ascribed in one manuscript. Brahmagupta's contribution to arithmetic and algebra. Brahmagupta gave the solution of general linear equation in chapter 18 of Brahma Sphuta Siddhanta. He further gave two equivalent solutions to the general quadratic equation. The four fundamental operations, namely addition, subtraction, multiplication, and division, were known to many cultures before Brahmagupta. This current system is based on Hindu-Arabic numeral system and first appeared in Brahma Sphuta Siddhanta. Brahmagupta also worked on various geometry problems. For example, in chapter 12 of his Brahma Sphuta Siddhanta, Brahmagupta provides a formula which is useful for generating Pythagorean triplets. Brahmagupta's most famous result in geometry is his formula for cyclic quadrilaterals. It was that given the length of the sides of any cyclic quadrilateral, Brahmagupta gave an approximate and an exact formula to find a figure's area. Brahmagupta dedicated a substantial portion of his work to geometry. One theorem gives the length of the two segments a triangle's base is divided into two by the altitude. Brahmagupta's Brahma Sphuta Siddhanta is the first book that provides rules for arithmetic manipulations that apply to zero and to negative numbers. The next mathematician we are going to discuss is Bhaskaracharya and his contributions. Bhaskaracharya was an Indian mathematician, astronomer, and an engineer. He is believed to be born near Khandesh region of Maharashtra. Here is a small overview about Siddhanta Siromani, which was supposed to be Bhaskaracharya's major work. In this picture, you can see in the corner there is a Pythagorean theorem, which is about right angle triangles. His first section was Lilavati, also known as Patiganita or Ankaganita, which consists of 277 verses. It covers calculations, progressions, measurement, permutations, and other topics. The second section of Siddhanta ceremony was Bijaganita, which has 213 verses. It discusses zero, infinity, positive, and negative numbers. It also discusses indeterminate equations, which is now called as Spell's equation, and it is solved using the Kuttaka method. The third section of Siddhanta ceremony was Graha Ganita. It is about treating the motion of planets. He considered their instantaneous speeds. It consists of 451 verses. He also contributed in arithmetic and algebra. The Lilavati was divided into 13 chapters, which covers major branches of arithmetic, algebra, geometry, and a little bit of trigonometry. It included definitions, some properties of zeros, properties of divisions, rules of operations with zeros, and he also did an extensive work of negative numbers and surds. He also worked on estimation of pi, arithmetical terms, methods of multiplications, squaring, problems involving simple interest, compound interest, the rules of 3, 5, 7, 9, and 11 divisibility rules, indeterminate equations, integer solutions of first and second order. His work in astronomy was as follows. There are 12 chapters covering mean longitudes of planets, true longitudes of planets, the three problem of diurnal rotation, which refers to the apparent daily motion of stars around the Earth, or more precisely, around the two celestial poles. It is caused by Earth's rotation on axis, so every star apparently moves on a circle, which is called as diurnal circle. Synergies, lunar eclipses, solar eclipses, latitudes of the planets, sunrise equation, and many more such things were done in his book. He worked in calculus as follows. His work, The Siddhanta Ceremony, is an astronomical treatise, and it contains many theories which were not found in earlier works. Bhaskaracharya uses this result to work out the position angles of the ecliptic, which is a quantity required for accurately predicting the time of an eclipse. In computing the instantaneous motion of a planet, the time interval between successive position of the planets was not greater than a truti. A truti is nothing but 1 upon 33750 of a second, and his measure of velocity was expressed in this infinitesimal unit of time. Now we will move to the next mathematician, Varaha Mihira, and his contributions. Varaha Mihira is also called Varaha or Mihira and was an astrologer, astronomer who lived around Ujjain. In his Panchasiddhantika, Varaha Mihira refers to the year 427 of Shakakala. Identifying this calendar era with the Shakakala era places Varaha Mihira in the 505 CE. Varaha Mihira must have lived after Aryabhatta, whose work he refers to. In 505 CE, Varahamihira composed the Panchasiddhantaka. The chronological order of some of the works of Varahamihira are as follows: Panchasiddhantika, Rajajataka, Bradayatra, Yoga Yatra, Brada Vivaha Patala, Brad Samhita. The next mathematician is Sridharacharya and his contributions. Sridharacharya was an Indian mathematician known for two extant treatises about arithmetic and practical mathematics, Patiganita and Patiganita Sara. He was mentioned by Bhaskara too and made apparent reference to Brahmagupta. Govindaswamin quoted a passage also found in Patiganita Sara, and overlapping material is found in the work of Mahavira, from which historians estimate that Sridhara to have lived in the 8th or the 9th century. He gave an exposition on the zero. He wrote that if 0 is added to any number, the sum is the same. If 0 is subtracted from any number, the number remains unchanged. If 0 is multiplied by any number, the product is again 0. In the case of dividing a fraction, he has found out the method of multiplying the fraction by the reciprocal of the divisor. He presented a method of completing the square to solve quadratic equations, sometimes called Sridhara's method or the Hindu method. Because the quadratic formula can be derived by completing the square for a generic quadratic equation with symbolic coefficients, it is called Sridharacharya formula. The next topic is about Madhava of Sangamagrama and his contributions. Madhava of Sangamagrama was an Indian mathematician and astronomer who is considered to be the founder of Kerala School of Astronomy and Mathematics in late Middle Ages. Madhava made pioneering contributions to the study of infinite series, calculus, trigonometry, geometry, and algebra. He was the first to use infinite series approximations for a range of trigonometric functions. Little is known about Madhava's life. However, from scattered references to Madhava found in diverse manuscripts, historians of Kerala school have pieced together information about the mathematicians in a manuscript preserved in the Oriental Institute of Baroda. Although there is some evidence of mathematical work in Kerala prior to Madhava, it is clear from citations of Madhava provided the creative impulse for the development of a rich mathematical tradition in medieval Kerala. Madhava developed the power series expansion for some trigonometry functions, which were further developed by his successors at Kerala School of Astronomy and Mathematics. Madhava also extended some results found in earlier works, including those of Bhaskaracharya or Bhaskara II. Madhava's contribution to infinite series and calculus. He discovered infinite series for the trigonometric functions of sine, cosine, tan inverse, which is also called as arctangent, and many methods for calculating the circumference of a circle. One of the Madhava series is known from the text Yukti Bhasa, which contains the derivation and proof of the power series for inverse tangent discovered by Madhava. In his text, Jesta Deva, he describes the concept of a series. Except for a couple, most of Madhava's original works have been lost. He is referred to be in the work of subsequent Kerala mathematicians, particularly in Nilakanta Somayaji Tantra Sangraha, as a source for several infinite series expansions, including sine theta and arc tan theta. In 16th century text, Mahajanana Prakara cites Madhava as the source of several series derivations for pi. In Jeshtadeva's Yuktibhasa, written in Malayalam, these series are presented with proofs in terms of Taylor series expansions for rational polynomials like 1 upon 1 plus x square, where x is equal to tan theta. Explanation for Madhava's sign table and method of approximation. Madhava composed an accurate table of signs. Madhava's values are accurate to the 7th decimal place. Marking a quarter circle at 24 equal intervals, he gave the lengths of the half chord corresponding to each of them. It is believed that he may have computed these values based on the series expansions. The text Sadrathanamala appears to give the astonishingly accurate value of pi 3.1415 and so on up to correct 17 decimal places. Here is a list of Madhava's works. With this, the second lecture on generic IKS, Ancient Indian Mathematics, Overview and Contribution finishes. I, Pratul Gadagkar, thank you for watching the video.